The first problem on homework number 3 deals with finding the DTFT of simple sequences like this. We are given x of n and h of n. What is x e to the j omega? We know that the DTFT of the delta function is 1, and the DTFT of a shifted delta function should be e to the negative j omega a, where a is the shift. From this, the DTFT of xn comes out to be 1 plus 2 times e to the negative j omega times 1. The DTFT of h turns out to be 2 minus 1 times e to the negative j omega. In part B, we are asked to calculate y e to the j omega as the product of the two, because we know that the convolution in time domain is simply a product in the frequency domain. So we simply multiply the two DTFT expressions with each other. We get 1 plus 2 e to the negative j omega. Simple multiplication with 2 minus e to the negative j omega. Simply multiplying them together, we get 2 minus e to the negative j omega plus 4 times e to the negative j omega minus 2 times e to the negative 2j omega. And simplification yields 2 plus 3 e to the negative j omega minus 2 e to the negative 2j omega. So this is the DTFT of y. Now we are asked to find the time domain y of n as the inverse DTFT of y e to the j omega. So remembering the relationships between the DTFT relationships between delta function and 1 and the shifted delta function and the e to the j omega a, we can write the inverse DTFT of 2 is simply going to be 2 times delta n, because it's just 1, and the inverse DTFT of 1 is the delta function, plus 3 times the inverse DTFT of this guy is the shifted delta function, and the shift is just 1, so it's going to be delta n minus 1. The inverse DTFT of this guy will be minus 2 times, this is e to the negative j omega 2, so the delta function is also shifted by 2. So we have obtained y of n as the inverse DTFT of y e to the j omega without actually having to do the convolution. In part C, we are asked to do the convolution directly, as in xn convolved with h of n. The expressions were delta n plus 2 times delta n minus 1. This was our x of n. Convolution h of n was 2 times delta n minus delta n minus 1. So this is x of n here, this is h of n here, and we are going to convolve them. So convolution with the delta function is a very straightforward process. Delta function convolved with the delta function is simply delta function. The delta function convolved with anything is the same thing. So these two would yield negative delta n minus 1. Then doing these two, we get 4 times, so the delta function convolved with anything is the delta function. Then finally these two, both of them are shifted delta functions, so the shifts will just get added together, so that's negative 2 delta n minus 2. Simplifying yields 2 times delta n plus 3 times delta n minus 1 minus 2 times delta n minus 2, which is the same as the expression we obtained from the IDTFT. So by knowing this problem, we should be able to find the DTFT of simple sequences like these. We should be able to find the inverse DTFT of simple sequences like these, and we should already be knowing convolutions of simple functions like this from the second homework.